So today we are looking at section 1.5. It's all about segments and their measures. Our biggest objective for today is to use the segment addition postulate. We're also going to use a couple of the vocabulary terms that we wrote down yesterday. We'll revisit the idea of what it means to be a congruent line segment. We'll talk about length a little bit too. So a nice little lesson all about segments and their measures. All right, so we have a postulate on the board. It says if B is between A and C, then AC equals AB plus BC. That sounds like a lot, right? Let's go ahead and draw it. So we have a point B. That point is between A and C. Everybody with me so far? All this is saying is that if you want this whole measure, you would just add the measure of the little guys. So let's say this one is 2 units. This one is 3 units. How long would the whole thing be? 5. That's all this is saying. So it makes it sound very complicated. But all it's saying is if you have one long segment and 2 smaller segments that make that long segment, you can add the smaller ones together to find the length of the big one. So, honestly, quiet down. On stuff like this, one of the biggest mistakes I see is that people are giving me the answer to a question that I'm not asking. So, before we do any sort of calculating or answering, I want you to find the segment that you're looking for and highlight it. So I am looking for the length of segment ST. ST is the long one. How would I find the long one if it's made up of 2 smaller ones? You add them. So 7 plus 8 is 15 is our answer. That's it. All right. On the next one. Let me get a different color going. So now I'm looking for ST, but ST is a littler segment here. It's not the whole thing. They already gave me the whole thing. The whole thing's 25. So we're going to start with 25. How do you think I'm just going to find this little guy?
20 plus 5.
Just make up numbers? No. The whole thing is 25. This little piece is 11. So how could I find this one? Subtract. The two little ones add together to give me 25, right? So I can just do it in reverse. 25 minus 11, that gives me 14. That's the way I would do it. Now, other classes, other teachers will make you write an equation every single time. Does anyone love algebra? You love algebra? Yeah. So, yeah, we can show you how to write an equation. So the smaller segment here is ST, right? Plus 11 would have to give us the whole thing of 25. And then you subtract the 11 from both sides. I don't require this of you, but it might help some of you get the problem started, especially if you're staring at it and you're like, I don't even know where to begin. Okay?
You can always, too, just every time, just like write out an equation. You don't even have to kind of fill out all the numbers and everything. Okay, obviously 2 things have to add up and give you an answer. And then you can plug in your numbers from there. So I'm looking for this, so we can call it X. And then when we have 11, it's going to give us 25. That works. So you know which number you're looking for. Looking for some something else to equal 25, plus 11 equals 25.
Did everybody hear that? And then this guy's always like the whole segment. So if you wanted to do that same fill in the blank scenario up here, you would just have the 7 and the 8 on the same side, and then it would equal the whole thing. Just depends what you're given. Any questions? So just draw the little segment. The map on the board, though, helps you see when we would use this information in real life. So let's say you're on a road trip, right? Everybody loves a good road trip. You're in Georgia, it appears. You start at Athens. You drive 80 miles. Let's say you stop for lunch in Macon. Get back in the car. You drive 90 more miles, and boom, you're at Albany. I want to know how far you drove that day. So we can do, yes, some people can look at this and say, I drove 170 miles. If that's you, great. Some of you aren't quite there yet, and that's fine. That's where you might need to go back to the original information that we learned with that segment addition postulate. That when you have two smaller segments, they add together to make the longer segment. So I know that the 80 and the 90 are the smaller ones, and I'm looking for this bigger one. When we're looking for something in math class, we usually use a variable like an x. And then the 80 and the 90 are on the same side of the equal sign, so you just add them, and you get 170 miles. So either way is fine with me. If you want to show me your work and write me an equation, go for it. If you can look at this and like road trips are your thing and you're like, boom, I know it's 170, I'm okay with that. I don't want you to do work just for the sake of doing work, okay? Any questions? So yesterday we wrote this definition down already. Congruent means that they have the same length. And we talked about it a little bit yesterday when we learned the vocabulary term length. You know, that means they have the same measure. This is what it would look like in a diagram, though. That's why I want to remind you again what we talked about yesterday. So, if it's marked the same way, you know that it's congruent. And if it's congruent, you know they have the same measure. So, for example, if I said this bottom segment was 10, what would this guy across be? 10, because they're marked the same way. If I told you this guy was 4, what would this guy be? 4, because they're marked the same way, they're congruent. Any questions? Now, on your homework, you'll have a few questions like this. The good thing is that they're already graphed for you on your homework. So you don't have to go back and graph them. But for right now, we're going to graph them. So this says, we have these 4 points, right? And again, you're just watching, soaking it all in, preparing yourself for your homework tonight. We have to graph these 4 points. So point A is at -2, 3. Do you guys remember from algebra how to graph that?
Yes.
You go left 2, up 3. Is that ringing any bells?
Yeah.
Okay, good. Then we have point B, which is at 3, 3. So you go right 3, up 3. And that is a segment. All right, we have 2 other points, C and D. C is at -3, 4. So 1, 2, 3, 1, 2, 3, 4, right there. And then D is at -3, -1. So 1, 2, 3, and 1. So this is C and this is D, and we connect them. The question asks if these are congruent. Congruent means what? Same length. Now, length is really easy to find on a coordinate plane because you can just count the number of spaces. So 1, 2, 3, 4, 5. These are 5 apart. Now count here. 1, 2, 3, 4, 5. What? I lost count. Hold on. 1, 2, 3, 4. It is 5, right?
Mm-hmm.
So are these congruent? Yes. Very good. The ones on your homework will look just like this, but there's a few more segments on the graph, and it asks you which 2 are congruent. So you just count the length of all of them, find the 2 that have the same length. So go ahead and do your summary in your notes. What did we learn today? Today we learned a little bit of algebra, reviewed some algebra skills. But what did we learn? What was the new stuff? Yep. Today we learned about segments and their measures. Good. Segments. You can't say you learn geometry every day. Because while that is true, that's not helping you review your notes, and it's also not going to get you the points for your notes when we grade your notes next week. All right, I'm going to leave the other 2 questions up to you. Make sure you get them done in your notes. So tell me what questions you still have. We'll start class tomorrow by talking about any questions that are still lingering. And then write yourself some sample test questions, at least one. What could I ask you about this stuff? Are we good?